Good morning, everyone. Welcome back to the another session. This is about binary search tree. This video is about binary search tree. This is also a tree, and where it is belongs to a kind of a binary tree. Binary search tree. In short, I am calling this as BST. BST is said to be binary search tree is said to be binary tree. Means what? Every binary tree will have at most two children. Every binary tree every binary tree will have at most two children. That means it can have 0, 1, 2 children. Now when I am telling binary search tree is said to be binary tree, that means binary search tree can also have at most two children. Every binary search tree can also have at most two children. And this also having one more special behavior. Every binary search tree will have a kind of behavior to arrange the nodes. Will have a kind of behavior to arrange the nodes inside of the tree, that is left child subtree should be less than from root node. Left child subtree less than from root node, and right child subtree should be greater than from root node. Now see this one. So every binary search tree will have at most two children. Now what these two children's? Left child and right child. Now left side subtree of every binary search tree will be arranged to satisfy this following phenomena, that is left child subtree. Not only the left child, entire left child subtree should be lesser from root node. Entire right child subtree should be greater from root node. Right? Now let's see some example. Right. Now in my example I am taking the first node, which is 20. Now 20 is called as what? Root node. 20 is my root node. Now as I said, this belongs to a binary tree family. Now this will have at most two children. At most two children. Now the left child value should be lesser from root node. So you can take less than value of any. So I am taking 15. Right. And the right child value should be greater from 20. So I am taking 25. This is the left child. And this is the right child. Right? Now look at this tree of three nodes. Now this tree of three nodes can be called as binary tree because it is having at most two children. And it is also called as binary search tree because the left child is lesser from root node. The right child is greater from root node. Hence it is binary search tree. Okay, this is binary search tree. Now let's see some example. Example 2. Construct a binary search tree with the following elements. Those elements are 12, 7, 9, 20, 5, 11, 6, 18, 44, 50, 32. Consider these elements. Consider these elements to construct the binary search tree. Okay. Now let's see how we will have to construct the binary search tree. Okay. Right. Now once again we'll write the elements which are 12, 7, 9, 20, 5, 11, 6, 18, 44, 50, 32. Now these are my elements. Now with what I wanted to construct a binary search tree. Right. Now 12 is my root node because this is my first value. This is my first value and which I am considering as root node. Now if it is my root node, all the elements which I wanted to put inside that will be on left side and right side. Right. Now left side is what? Lesser from 12. Right side should be greater from 12. Now let's see the second element. Now second element is what? 7. Now 7 is lesser from 12. So it should be left child. Right. Now put a place for 7. Now the third element is 9. 9 is lesser from 12. Okay. 9 is lesser from 12. So where we should go? We have to put a place in left side because 9 is lesser from 12. Right. Now come down to the second level. Now here we have the other element which is 7. Right. Now this is your root node. Okay, for this left subtree, this is my root node. Now again you have to compare 9 with this 7. So now 7 is lesser than 9. 9 is greater than your root node, right? When a node is greater than the root node, we have to place that in right hand side or a right child. Okay. Now the third element is 20. Now come see the 20 with 12. Now 9 is lesser from 12, so left child. Left child is 7. 9 is not equal. 9 is greater from 7, so it should be right child of 7. Right? And next is 20. So again 20 we have to compare with what? 12. So now 20 is greater from 12. 12 is my root node. Now I have to check the condition. My new node which is 20 has to be right hand side. Okay. Now it is right hand side because it is greater. And next element is 5. Now again check with 5. Now it is right child. Now 5. Now 5 is what? Lesser from 12. 5 is a less than value or lesser value from 12. So as it is a lesser value, we have to get a place from left subtree. Now left subtree is having 7. Now again 5 has to be checked with 7. So now 5 is lesser from 7. So when it is lesser, you have to put a place at left hand side. Right? Now next is 11. And 11 is where you have to place 11. 11 also has to be checked with 12. So it is lesser 12. So 11 will be get a place at left hand side. 11 will get a place at left hand side. Now left hand side subtree is what? 7. Again you have to compare 11 with 7. Now when you compare, it will go to right hand side. Now come this side. Again you have a node here. Now again you have to compare 11 with 9. Now when you compare, 11 is found greater than 9. So you have to place right child of 9. You have to place right child of 9. And next element is what? After 11, 6. Right, now again 6, 6, 12 will compare. Now 6 is lesser, so left hand side, left child subtree will go. Now again you have to compare 7 with 6, found to be lesser, come to left part, and found to be greater than 5, so right hand side or right child of 5. Next again 18, 18, again 18 you have to come down. Now 12 is lesser from 18, so 18 should be where? Right side, right child subtree, because it is greater. Now right child subtree, you have 20 already here. Now compare with 20. 18 is lesser from 20. Now okay, put a place. Left child to 20. Next is 44. Where 44 will go? Right child to 20. Next 50. Where 50 will go? Where 50 will go? Right child to 44. Where 32 will go? Left child to 44. Did you understand? When you are given with a notes, you have to compare first of all with root node. Okay, after you compare root node, you will be finding whether it is lesser value or greater value. If it is lesser value, find a place at left hand side. If it is greater value, find a place for right hand side. Now when you are having again a subtree, you have to compare with that node and will be giving proper place to all these nodes. If you look at this, you can see this tree as left hand side is lesser, right hand side is greater, and this middle element, right? Now something like of your binary search, how binary search will looks like. So given elements will be sorted and we will be finding the middle element. So after you find the middle element, left side elements will be lesser values, right side elements will be greater value. Yes, something like. So binary search tree, yes, it's a kind of binary tree. You can see it. You will be having only at most two children. At most two children. First condition is satisfied, and the second condition is what? Left child subtree should be lesser from root node. Right child subtree. This is your left child subtree. All the keys of left child subtree are lesser from 12. All the keys of right child subtree should be greater from root node. Now this is what binary search tree. Okay, right. Now let's see binary search tree operations. Let's see binary search tree operations. So basically we'll perform 4 operations. Search, that is finding a key element. Finding a key element in binary search tree. And insertion. Inserting a node into binary search tree. Deletion. Deleting or disconnecting the link. Disconnecting the link from binary search tree. Fourth is traversal. That is displaying or visiting of nodes in binary search tree. Okay, so these are what the binary search operations, and this is what the way of constructing the binary search tree. And this is what the formula on base we will be constructing the binary search tree. So next video we'll be going to see BST operations. Okay, how operations will be performed on binary search tree. Okay, thank you all.